All right, here we go. In this one, we're going to be talking about boolean, relational operators, and if statements. As you can see, there's a little bit of coding that's going to happen when we get to that section. I invite you to code along with me. I've already loaded up my IntelliJ. We're ready to go. So, what is printed by the following code segment? Not a trick. I've got x, which has a value of 2. We're going to do 2 plus 7. We get 9. Okay? What is printed by this code segment? Okay, what we get out of this is true. All right, so in Java, an expression such as x is less than 7 has a value in the same way that x plus 7 has a value. Less than, greater than, and other relational operators will evaluate to true or false. The values true and false are not numbers, they're not objects, they belong to a primitive data type called boolean. Okay, this is coming from George Boole, who developed Boolean algebra, which is looking at these types of things, true or false types of scenarios. Okay, so here in this slide, I'm showing you Boolean is one of those 8 primitive data types. It is a reserved word. That's the reason why it's kind of colored this way. Actually, it's the same thing with true. This is a reserved word. Now, a Boolean variable can only have one of 2 values, either true or false. Right here, I'm saving it into a Boolean variable. And then when we print it, we're going to get true. That's going to show up in the console. False is my other option. Okay? A Boolean variable consumes 1 bit of memory, as a single bit can be used to represent either outcome. I like to think of 0 as false and 1 as true. This is pretty interesting, right? This is a bit, as we learned, is the smallest unit of data possible. Right? 8 bits is 1 byte, and we actually have 4 bytes in order to make up a single integer. This is way smaller. 1 bit, super tiny. Right? So a Boolean variable is as small as it gets. In Java, Boolean, true, and false are all reserved words. And that leads us into relational operators, because we saw that less than, right? We saw a mention of a greater than. Every relational operator will produce a Boolean value, and there's 6 of those. What am I saying? In the same way that addition and subtraction produce like integers, numbers, these operators, these relational operators, produce Boolean values. Right? We have our less than, greater than, less than or equal to. Right? I have to use 2 symbols here in order to create this one symbol, and that's because I can't really underline this thing. Same thing here. Okay, here I'm having to use double equals, and I want you to think about why for a moment. Why do we have to use double equals? Why not just a single equal sign? Well, that's because the single equal sign is the assignment operator. Essentially, it's already taken. It has a use already in Java. So we use these double equal signs to look for equality, to check to see if these 2 things are equal. And then we have this little exclamation mark, which is going to mean not. So we see not equal. Okay, more on that exclamation mark later. These 6 relational operators are used to compare the relationship between 2 primitive data types of comparable types, right? Notice we're talking primitive data types, so not objects. These aren't really used for objects at all. And note this, comparable types. More on that in a moment. Right? Our less than symbol is going to evaluate to true if the number on the left-hand side is less than the number on the right-hand side. Otherwise, we get false. Here's a quick example. I'm using some variables just to kind of vary it up. So x has a value of 3, y has a value of 4. We're going to ask, is 3 less than 4? Well, yeah, we would get true out of that. Okay, what I mean by this relational operator is producing a value. Yeah, that this true is coming from this operator. Our greater than is going to evaluate to true if the number on the left-hand side is greater than the number on the right-hand side. Otherwise, we'll get a false value. Right? Same values. Here, I'm varying it up again. I am taking the value that's produced by the relational operator and saving it into a variable. Right? A Boolean can be true or false, and that happens to be what these relational operators produce. So you could add steps as necessary. Right here, I'm saving the result into a variable. You don't have to. We didn't previously. right? Here I printed it directly. It depends on what your program needs. Here I'm saving it into the variable and then later printing the variable, and you see we get a false value. Our less than or equal to evaluates to true, blah, 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 blah. Here's our example. We're asking, is 4 less than or equal to 4? Sure is. And our greater than or equal to, as you might imagine, and here's where I'm showing you comparable data types, right? We've seen kind of issues with integer and double. I can't save a double into an integer variable, for instance, but here I'm taking a double and comparing it to an integer. These are comparable data types, and so this works, right? 4.2 greater than or equal to 7. It is not, so you get a false value. Okay, so note that these 4, less than, greater than, less than or equal to, greater than or equal to, only work with numbers. Each of the following would give you a syntax error, right? Earlier I showed you is, like I kind of think of false as a 0 and true as a 1. And so I was kind of curious, like, are they treated as such? That's not the case, right? If you were to plug this in, you're going to get a syntax error, which means IntelliJ is going to underline it with a little red squiggly. Here, so we've used double quotes. Here I'm using single quotes, and that's on purpose. Keep in mind, relational operators are for primitive data types, right? So these aren't strings. They're primitive data type. What do you think these are? How do I know they're primitive data type? Well, I'm using my relational operator to kind of compare them. These are actually char, right? Short for character. These are single characters. The single quotes are kind of what indicate that. Okay. Our equals evaluates to true if the two values are equal. Here, I'm doing some math kind of on the spot. Okay, in order for this to work, what it would mean is that our arithmetic operators have a higher precedence than our relational operators. What am I saying? This is going to happen first, right? We're going to come in here and do the addition first, and then check to see if they're equal. That's what I mean by the precedence level. And so these arithmetic operators will be evaluated first in the same way that multiplication gets evaluated before addition. Right? That's because multiplication has a higher precedence. Same thing here. Our arithmetic operators have a higher precedence than our relational operators. So we'll do the math, and then we're going to ask, is 3.14 equal to 3.14? And the answer is yes. Okay, not equals evaluates to true if the value on the left-hand side is not equal to the value on the right. 3.0 not equal to 3. This one's interesting because I'm ultimately comparing a double to an integer, right? These are comparable data types, and it would say false. False, they are not equal. That is, they are equal. So this does work. Okay, note that equals and not equals work for all primitive data types. We have 8 primitive data types total. 6 of those are numbers. 2 of them are not. Those 2 being boolean and char. So here I have a boolean variable with the value of true. I then want to know, is that boolean variable, which has a value of true, does true equal false? Well, that is false. True doesn't equal false. So this is going to produce a false value, which I'm saving into this boolean variable and then printing later to kind of show the result. Here I have a char, right? This is one of our primitive data types. I'm saving in a char. By the way, when we use double quotes for a string, we call it a string literal. Well, this is a character literal. The opposite of literal is going to be variable, right? I'm saving the literal into the variable. This variable can change, or the literal, it can't. This is like the number 7. I'm going to save this char into this variable, and then I'm asking, is that char equal to A? True. Okay. Boolean values and relational operators are necessary to make decisions in Java in every programming language. Like if statements are like the quintessential logic in like every programming language. Boolean values and relational operators are necessary to make decisions in Java. If statements are control statements that alter the normal flow of a program by executing a different set of statements if a condition is met. Here is our syntax. We're going to have if, then some parentheses. Inside the parentheses is where our condition is going to go. We're going to have some curly braces that indicate the body of the if statement, and then I can have multiple statements inside of that. Okay? This is something all control statements have in common. We're going to see more control statements later. Loops are control statements. Control statements alter the flow of the program. Like most control statements, if statements have a head or header. Right? We have a head or header. In the head is going to be a condition. The condition must evaluate to either true or false. Either true or false. Right? A boolean value. We have a body indicated by the braces. And then we have any number of statements inside the body of the if statement. In theory, 1, 0 may be a possibility. Not practical, obviously, but one statement, as we're going to see with the stuff that we're going to code today, but you can have multiple. When executed, the condition of an if statement is checked. If the condition is true, all of the statements in the body will be executed. If the condition is false, we're going to skip over the body, and it's as if the if statement never occurred. Let's look at an example. I have an integer x with a value of 7. Here I'm going to ask, is 7 less than 10? Well, that's true. What we would do in this case is enter the body of the if statement, and what happens is we print off x is less than 10. Okay, so this would actually print that. Let's look at a slightly different variation. I'm going to take x, which has a value of 7, and ask, is 7 equal to 10? This is false. I would get a false value here in my condition because of this relational operator. So we would skip over the body, and literally nothing is printed. This is if this SOP doesn't exist. Okay, with that in mind, let's code positive, negative, or 0. I want to basically write a program that prompts the user for a number, and then we just tell them. Like, we're going to vary a statement to say if it is positive, if it is negative, or if it is 0. So in IntelliJ, I'm going to do a new project by going to File, New Project. Our JDK is already selected, so we'll go Next. We'll go Next. I'm already in my Principles folder, so I'm going to go ahead and create the project. I'm going to call it pos-neg0. I'll expand my project folder, right-click on the SRC, make a new Java class, which I'm going to call pos-neg0. Okay. What I want to do is bring in scanner. We're going to need, let's go ahead and plug in our main method with PSVM. My first step to implementing scanner is import scanner. My second step is going to be to construct the scanner object. I'm going to create a scanner. I'm going to call it input. That's a new scanner that reads from system.in, the keyboard. I'm going to prompt the user. I'm going to use an sout, right? That's our short key for an SOP. And we're simply going to say, please enter a number. Okay. Appropriate data types, and I guess we can have positive, negative, doubles, so why don't we do that? I'm going to create a double, and we're going to use that double to then capture the next double that the user enters. Okay, so these are my 4 steps implementing scanner. We've imported, we constructed our scanner object, we've prompted the user. This step's not necessary, but quite good. And then we're actually going to save their input into a variable, so now it's in my program. For the rest of the program, I'm working with num. Okay, I want to figure out, is num positive, negative, or 0, and then kind of display a message accordingly. So We're going to use if statements to basically change this up. I'm going to plug in the syntax for my if statement. We're going to have if parentheses. And then I'm going to go ahead and throw in some braces indicating the body. So this is the syntax. Right? It's very simple, very clean. Notice that this is orange. If is a reserved word, just like double, just like public and static. Okay. So I have a head, which contains a condition. Head of the if statement contains the condition. Okay, the condition of this has to evaluate to either true or false. Notice IntelliJ is mad at me right now because there's an expression expected. What I want to do is figure out, is this number positive, negative, or zero? So I'm just going to check for positive first. If num is positive, how do I know? Well, we know it's positive if it is greater than 0. So I'm going to take my num and ask, is it greater than 0? If this is true, we'll execute whatever is inside of these braces, whatever is in the body. In this particular case, I just want a simple output message. Right? We'll do a system.out.print line, and we would say something like num is positive. Why don't we test this? Why don't we test what we got so far? I'm going to right-click in free space and tell it to run. And here we see our program is running. It says, please enter a number. I'm going to enter 7. 7 is positive. Something of note, right? I entered an integer, but we're capturing it as a double. You can fit integers inside of doubles, no problem. Once it's inside the double, it is treated as a double for the rest of the program. So when I get down here and I try to reference num, it is in fact a double, so we do get that 7.0. Okay, I'm going to run it again, but I'm going to put in a negative number, and I kind of want to show you what happens. Let's do a negative 7. Well, in that case, nothing happened. Why? Well, we gave it a negative 7. Negative 7 is stored here in this double. We then ask, is negative 7 greater than 0? It is not. This is false. So what happens with our if statement is we're going to skip the body. It's as if it doesn't exist. And notice that nothing printed. And I reached the end of my program. Okay, so let's add in an if statement to handle negative numbers. Again, here's our syntax. We're going to bring in a condition. We're going to say if num is less than 0. Well, if that's the case, I'm going to do an sout and say something like num is negative. Okay, let's try this. I'm going to enter a positive 7. And we're going to see 7.0 is positive. What happens? 7 comes in. We save it into num. And then ask, is 7 greater than 0? Yes. We're still in the program. I'm going to ask, is 7 less than 0? No. So we're going to skip over the body of this if statement, and my program is done. Last, as you can imagine, if num is equal to 0, we're going to do an sout that just simply says num is 0. You got to appreciate my enthusiasm for the positive, my reluctance for the negative, and my nonchalant, not narcissism, nihilism, I guess, for 0. Anyway, all right, let's go. I'm going to this time put in the number 0. 0 comes in. It's in my variable. We're going to ask, is 0 greater than 0? No, that's false. So we're going to skip this. We're then going to ask, is 0 less than 0? That's also false, so we skip over this. We ask, is 0 exactly 0? Yes. Something of note, we're comparing num, which is a double, to this 0, which is an integer. Those are comparable, right? I can verify that num is a double, because A, the data type here, but of note, whenever we go to print, right, it's 0.0. So whenever I get to this if statement check, I'm asking specifically, is 0.0 equal to 0? And that still works because doubles and integers are going to be comparable data types for relational operators. All right, let's recap. The values true and false belong to a primitive data type known as boolean or boolean if you are from Louisiana. Less than and greater than belong to a category of operators known as blank operators. These are called relational operators. May also be called conditional operators. I haven't really looked into that too much, so don't worry about it. How many relational operators are there in Java? There's going to be 6, and then I'm going to ask you, what are they? What are the 6 relational operators in Java? Well, we have less than, greater than, less than or equal to, greater than or equal to, equals, and then not equals. Okay? I got this guy because I can't underline. The assignment operator has already claimed the single equal sign, so we got to use double here. And this exclamation mark means not. So this reads as not equals. Note that order does matter, right? If I were to flip this, right, and I said equals less than, that is not a symbol. Same thing here. If I was to flip this and said equals not, that is just not a symbol. The order matters, and it is in the order that you say it. Less than, equal to. Greater than, equal to. Not equal. The blank is the portion of the if statement header enclosed with parentheses. All right, looking back at my code, we're talking, what is this? That is going to be the condition. The condition of an if statement must evaluate to, and lots of students will snap say true. That's not what this question is asking, right? It is possible that the if statement condition evaluates to false. It can be true or false, right? We actually just had lots of incidences where I added in 0 and this evaluated a false, and this evaluated false, and this one evaluated a true. So the condition has to be true or false, a Boolean value. The portion of an if statement enclosed with curly braces is known as the body. And that's going to be it. So I will see you in the next one.